Even today, children may have heard the warning that if they are bad, they will find nothing but a lump of coal in their Christmas stockings. They may never have seen coal, may not even know what it is, but they know that a lump of it, indeed a lump of anything, is not something they want. Where oil is seen as a symbol of luck, coal is seen as a symbol of disappointment. It's easy, though, to imagine another culture, one with a greater appreciation of the past, and particularly of the ancient past, where coal's reputation would be quite different. In that culture, the lowly lump of coal would be revered as the fossil that it is. Before mammals appeared, before the dinosaurs evolved, before the continents glided and crashed into their current positions, that lump was alive. It was part of an enormous swampy forest of bizarre trees and gigantic ferns, monsters of the vegetable world, as one 19th-century writer described them, that are no longer found on Earth except for some that survive in greatly shrunken form. Most coal beds were part of the first great wave of plant life to leave the oceans and colonize the land, paving the way for animals to do the same and sheltering them as they took important evolutionary steps. In other words, coal is the highly concentrated vestige of extinct life forms that once dominated the planet, life forms that were themselves a critical link in the chain of environmental changes that made the emergence of advanced life possible. If coal were not so plentiful, one could imagine it lovingly displayed in museums, placed next to the generally much younger dinosaur bones, rather than being burned by the trainload. Even more fascinating than what went into coal, though, is what has come out of it, enough energy to change the world profoundly. For billions of years, almost every life form on Earth depended for its existence on energy fresh from the sun, on the, quote, solar income, end quote, arriving daily from outer space, or temporarily stored in living things. Like living solar collectors handily dispersed all over the planet, plants capture sunshine as it arrives and convert it into chemical energy that animals can eat. And plants don't just convert energy, they store it over time, holding that energy within their cells until they decay, burn, or get eaten, or, in rare but important cases, are buried deep within the planet as a fossil fuel. Animals eating plants take that stored energy into their bodies, where they not only store it in concentrated form, but disperse it through space. A flock of geese, a pod of whales, a herd of caribou, they are all, on some level, mobile battery packs. They gather solar energy that falls upon one patch of the planet and deliver it to another as they migrate. In this way, they make life possible for their predators, even when, for example, the snow is thick and there is not a green leaf in sight. Life on Earth is, in short, a vast and sophisticated system for capturing, converting, storing, and moving solar energy. The evolutionary success of each species depending in significant part on how well it taps into that system. In the animal kingdom, one of the species that can most efficiently turn the calories of its food into useful mechanical energy is our own. Humans need about half the calories that, say, a horse needs to exert the same physical energy. Our metabolisms are astonishingly energy efficient, and that undoubtedly gave us an evolutionary advantage over other species. Perhaps this advantage helped give us the big brains we needed to figure out yet another way to tap into the stream of solar income captured by plants: fire. By burning plants, especially plants we couldn't eat, like trees, humanity leaped beyond the physical limits imposed by its own gastric and metabolic systems and released far more solar energy than ever before. It was, of course, a momentous step. Fire is one of the distinguishing features of our species. Only people use fire, if by people we include the primates that would eventually evolve into people, because we began controlling fire perhaps some 500,000 years ago, long before Homo sapiens emerged. This new means of controlling energy reduced our vulnerability to the forces of nature, particularly during the long ice ages that repeatedly gripped the earth and helped make us fully human. Eventually, people stopped wandering across the land hunting and gathering food and began to grow it instead, a milestone archaeologists generally consider the beginning of civilization. Fire and the unusually stable climate that has prevailed over the last 10,000 years made this settled agricultural life possible. Fire let people clear land for crops, using much the same slash-and-burn methods threatening our rainforests today, and made digestible the cereals they planted. In these more permanent settlements, people eventually learned basic manufacturing skills, like firing pottery, baking bricks, and smelting metals, ways to make products that would last, for societies that would last, at least as long as they had fuel. Many of these early artisans turned to a fuel that would be an important bridge between wood and coal, and is akin to both of them: charcoal. Charcoal is wood that has already been partially burned. For thousands of years, charcoal was made by heaping wood into large piles or partially burying it, and then burning it in a slow, oxygen-poor smolder that left behind almost pure carbon. The resulting charcoal burned hotter and cleaner than wood, but the process of making it wasted much of the wood's original fuel content, putting an even greater strain on the forests. As civilizations and nations grew, trees disappeared, depleted by competing demands for fuel, timber, and land for crops. All these needs drew down the same stores of plant-captured solar energy, and those stores invariably ran short. The size of our fires and our meals, our cities and our economies, and ultimately our populations, were all restricted by the limited ability of the plants within our reach to turn the sun's light into a form of energy we could use. In this world of tight energy constraints, coal offered select societies the power of millions of years of solar income that had been stored away in a solar savings account of unimaginable size. Coal would give them the power to change fundamental aspects of their relationship with nature, including their relationship with the sun, but it would offer that power at a price. I haven't always viewed coal with such fascination. In fact, until recently, I seldom thought about coal at all. Like most people in developed countries, I had no obvious reason to do so. I wasn't mining it or buying it or burning it, and I hardly ever saw it used. As an environmental attorney for the state of Minnesota, I helped regulate some of the state's coal-burning industries, so I was familiar with the many pollutants coal burning puts into the air. Still, I only vaguely understood coal's sweeping impact on the global environment and on society. What really compelled me to look closely at coal was a case that focused my attention on one of the most profound environmental issues of our time: global warming. Minnesota is a cold state. Our winter temperatures are often the most frigid in the United States, outside Alaska. Lows of minus 50 degrees Fahrenheit are not unheard of in some northern counties. At this temperature, a bucket of water thrown into the air freezes before it hits the ground. Bananas get so hard that you can pound nails with them. Yes, this has been demonstrated. An exposed skin can freeze in mere seconds. This is not a place where the threat of a few degrees of global warming alarms the average shivering citizen. And because Minnesota is about as far from an ocean as you can be in North America, forecasts of rising sea levels cause even less concern. Even though we didn't necessarily think of ourselves as living on the front lines of global warming, a naive assumption as it turned out, Minnesota wanted to have some idea of the larger environmental consequences of its energy decisions. So, a few years ago, the state began a legal proceeding that tried to quantify the impact of its electricity use on global warming. Most of Minnesota's electricity, like that of the U.S. as a whole, comes from coal. So this meant trying to figure out what effect the emissions from our coal-burning power plants would have on the Earth's climate. When the proceeding began, few realized what an exquisitely sensitive nerve it would touch. Representatives of the nation's coal industry, including its most colorful and politically extreme wing, intervened in our hearing, helping to make the contentious administrative trial that followed one of the longest in state history. They brought in a phalanx of scientists who testified that Minnesota should ignore what the vast majority of their colleagues around the world were saying about climate change, and argued instead that the climate was not changing except in small ways we were all going to enjoy. Minnesota temporarily found itself on the front lines of the larger national battle over climate change. The industry's aggressive response was fueled by its recognition that climate change threatens its very existence. Climate change is mainly caused by burning fossil fuels, namely coal, oil, and natural gas, and of these fuels, coal creates the most greenhouse gases for the energy obtained. Today, the United States burns more coal than it ever has, almost all of it to make electricity. Although Minnesota's decision-makers flatly rejected the industry's notion that climate change would be limited to climate improvements, adopting instead the widely held consensus that climate change is a grave threat, we don't yet know whether the proceeding will have any effect on state energy policy. The effect of the case on me personally, however, was dramatic. I was left not only deeply concerned about the changing climate, but thoroughly intrigued by the lump of carbon at the center of the storm, this often overlooked fuel that reveals so much about us and the world we've built. The more I dug, the more I could see that a deep, rich vein of coal runs through human history and underlies many of the hardest decisions our world now faces. Following that vein in the intervening years has taken me far afield, from paleobotany to labor issues, from ancient history to modern geopolitics, and from the massive state-of-the-art power plant a few miles from my home to a primitive little coal mine in Inner Mongolia. This book is the result of that journey. I'm by no means the first person moved to write about the enormous impact of this combustible rock. In the late 19th and early 20th centuries, all kinds of people, engineers, plant scientists, businessmen, and theologians, were inspired to write books and articles for the general public in which they waxed poetic about the glories of coal. Even transcendentalist philosophers had something to say on the subject. In the mid-1800s, Ralph Waldo Emerson wrote this about coal. "Every basket is power and civilization, for coal is a portable climate. It carries the heat of the tropics to Labrador and the polar circle, and it is the means of transporting itself whithersoever it is wanted." Watt and Stevenson whispered in the ear of mankind their secret, that a half-ounce of coal will draw 2 tons a mile, and coal carries coal, by rail and by boat, to make Canada as warm as Calcutta, and with its comfort brings its industrial power. This quote stands out not just for Emerson's eerily apt choice of metaphor, but because it captures the world-changing essence of coal. It also reveals the 19th century's appreciation of how coal was letting humanity transform nature's cold, cruel world into one more comfortable, more civilized. Coal was no mere fuel and no mere article of commerce. It represented humanity's triumph over nature, the foundation of civilization itself. As another writer flatly put it, "With coal we have light, strength, power, wealth, and civilization. Without coal we have darkness, weakness, poverty, and barbarism." The reverence many people felt toward coal was often tinged with defensiveness because they knew that others still looked down on the commonplace fuel. Combating the...
To keep listening to this audiobook, I've left you a link in the description so you can do it, at no cost thanks to Audible's 30-day free trial.